to finish up the last two questions for the exam 3 review, we'll take a look at number 4, which again comes from the exam 3 review. We're limiting our domain for x greater than 0. We see the function here, so that's a good thing. X can't be 0 because if you the x in the denominator, and we have a natural log. We're asked to find the absolute maximum, and then here it says absolute minimum. That's a typo. We're going to see that that really should be absolute maximum. What I would suggest doing is first, let's just graph it and see what it looks like to see that we're getting a maximum, and then we'll use methods of calculus to actually do that. So 2 plus, so we'll enter in that function, and what I'm going to do is I'm going to do alpha, which gives me the f1, and when we do that we get a numerator denominator, so it just makes entering fractions a little bit easier. So 2 plus 5 natural log of x, and then we arrow down and put x in the denominator so we can see how it's looking. Okay. I'm going to do a zoom fit because I'm not quite sure what's going to happen with this. So I go to zoom. I'll show you. If you arrow up, you get there quicker. Oh, we got all these different ones I didn't expect, but I was expecting 0 right there, zoom fit. Let's see how that works. Enter, it's thinking. Okay, and yes, indeed, we see it goes up and then comes back down like this. So there's going to be a maximum right here. Why not use the graphing tools to actually find that? Again, if this was a multiple choice question, then you could, yeah, sure, this method would give you the answer. We need to find a left bound. So we move our little, call that little spider marker. Come on. This thing, it was working faster the last time. But anyway, we'll get there. So we got to be to the left of the maximum. That's slightly to the left. Enter. And then we've got to be to the right. So I'll go a little bit more, whatever. And then we enter our guess, and we're going to see we get that the maximum occurs at 1.8221 with a value of 2.7. So what did they want? They wanted the x coordinate. So we'll go ahead and write that down. For the maximum, x equals 1.8221. Okay, that's to 4 decimal places. Okay, so how could we find that using calculus? One method is we could just find the first derivative. And we have a quotient, so we want to use a quotient rule. So I'll just go with the numerator is 2 plus 5 natural log of x. The derivative of the numerator is just going to be 5 over x, because the derivative of natural log of x is 1 over x, so that's 5 over x. The denominator is simply x, and the derivative of the denominator is 1. And so we're going to put that together with the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. The denominator simply becomes the denominator squared. So in the first term, the x's cancel. X divided by x is 1. So we're just left with the 5. The negative needs to distribute, so we'll do that. So we'll find that the derivative of the function is going to be 5 minus 2 minus 5 natural log of x over x squared. We can simplify. 5 minus 2 is going to give us 3. And we're going to set this equal to 0 because that's what would give us a maximum or a minimum. And for this to have a max, or for this to be equal to 0, all we need is the numerator to become 0. Obviously the denominator we don't want to become 0. That would be undefined. So then we just set this up as 3 minus 5 natural log of x equals 0. Subtract 3 from both sides, so we get minus 5 natural log of x equals negative 3. Divide by negative 5, so that gives us that the natural log of x equals negative 3 divided by negative 5, which is positive 3/5. And then to solve a natural log, what we do is exponentiate each side. So this e in the natural log would cancel, giving us x equals e to the 3/5. That's an exact answer, but since they wanted to 4 decimal places, what do you want to bet that e to the 3/5 is equal to 1.8221? Let's hope it is, because that would make that means we got the right solution. So this is why we kind of want to do both solutions here. So let's do e raised to the 3/5 power. It's all up there. That's good. And what do you know? 1.8221. 1.8221. That's what we got. So of course, this method, the second method we use, that was this one here, is using calculus to figure it out. Now, we have not actually proved that this is a maximum with calculus. We could get the second derivative if we wanted to and show that it's concave down. We could also, again, if you really needed to justify our answer, what we would do is we would find the derivative of x at some value to the left and the right. So I would look at f of 1. So let's do that. And this is, again, if it was one of those open answers and says justify your answer, we really want to do this part, because this just says, okay, yeah, you found this. For all we know, really, at this point, it's where the derivative is 0, but it could be a minimum. So what we want to show is that f of 1, and then the other one I would take is f of 2. So we've gone to the left and the right. And if it is a maximum, with this being 1.8221, the x value, what we're going to see is that all we're really interested in is a sign, and we should see the sign of the first derivative would be positive to the left and negative to the right. Okay, so we would expect when we plug in 1 to this derivative, and again we use the switch color so it's a little more clear, and actually let me just give myself a little bit more room here. Okay. Switch to blue. So I'm going to do f of 1 would equal 3 minus 5 natural log of 1 over 1 squared. natural log of 1 is 0, right? Let's just verify that. It is indeed. So we get 3 over 1, which is a positive value. And again, that's what we were hoping for or expecting. That's, so we're increasing there. This has obviously a slope of 0, and then we just have to show that on the other side, looking at, say, f of 2, and we could go for any other one, that we're going to get a negative result. And for that, we get 3 minus 5 times the natural log of 2, which is going to be a number bigger than 0. What we have to do is see when then we multiply by 5. Is that going to be bigger than 3? Because then that would mean it's negative. We're going to get 2 squared in the bottom, which is 4. But the sign is all that we're interested in, and so we just have to see is 5 natural log of 2, is that bigger than 3? If it is, then we're done, and if it's not, we're in trouble. So 5 natural log of 2, yep, it's a little bit bigger than 3, so when we subtract in the numerator, we're going to get a negative number. In fact, negative 0.4657. Doesn't really matter what we get, but it's negative. And so we have now verified. We had a positive slope on the left, a negative slope on the right. That means a maximum. Okay, so we've justified that not only did we get the answer, but that it is a maximum. Okay. So again, multiple choice, we were done up here. We just needed to find it. Explanation, we want to take this full step of using the calculus to find our answer, or verifying that answer. I still would do the graphing part first, and then verifying, justifying, showing somehow with the calculus that we do have a maximum. And again, positive to the left, negative to the right. That does it. Okay, so now let's take a look at this last question we've got. We've got this function on a particular interval, and we're going to use the closed interval method to find both the absolute maximum, absolute minimum. It will occur because, again, it might occur at the endpoints, so those will be the places I would suggest maybe checking first, or I guess we're not really going to check them, but we're going to get them. So we want to see what happens at -4, comma, when x is -4, what is y? And then we're going to see when x is 8, what is y? So we're going to plug this in, and then the other thing is I'd like to just kind of look at the graph and see what it looks like. So I'm going to come back here, I'll clear this out, and see if I can move this over a little bit so that the function's still showing. So we're going to go with x to the third minus 6x squared minus 63x plus 8. Now one thing I'm going to go ahead and look at the table first before I go to the graph. Simply build the anticipation. So what I want is when x is 4, y is -276. So I've got and I can see that's actually not going to be an absolute minimum because it gets smaller after that. And then at 8, let's come over here, go down. Oh wait, from -4, sorry, -4. Be careful. Well, let's, while we're here, let's get 8. 8 is negative 368, so let's do that one. And we'll see that that's a potential for a absolute minimum probably. Let's see what we get at negative 4. Negative 4 we get 100, and so far that makes negative 4 the maximum and 8 the minimum. And we see, but see, from negative 4 it actually goes up, so we can see negative 4 is not going to be the maximum because negative 3 is bigger, so is negative 2. But so we could expect probably maybe a maximum somewhere between negative 4 and negative 2. I can see that there just from the table. And then the minimum, I'm going to say at 368, so it's the same type of thing. It's not going to be the endpoints because there's some values in here. Negative 370 is bigger, so at 6, see, we're not bigger, we're more negative. 7's more negative, so we can see the minimums and maximum are going to be on the interior of the interval that we have. And to verify that with the graph, we're going to go ahead and graph it. But before I get there, let's set up our window to go. I always like to make it a little bit bigger, so I'm going to go from, well, let's just do it, negative 4 to 8. So that's the x interval, and we'll have our endpoints there. The y's we're kind of seeing from here. We have a y value of 100, so I guess we could just try that. I usually go a little bit bigger, but well, maybe actually maybe we better go 150. And then the y, oops, I want the y maximum to be 150, sorry. And then my y minimum, if I get there, negative 368, so maybe let's go to negative 400. So our window should be set up nicely to show us what's going on when we go to the graph. And we do see that the endpoints are not the places. There's going to be a absolute maximum on the interior here, somewhere around negative 3, and absolute minimum here, somewhere around between 6 and 7-ish in there. Okay. And again, we could use the calculator, and why don't we, to find those values. So the maximum, again, we can, and again, what it's asking for when it says location, that is the x value that we're looking for. Of course, we have the y values to do as a comparison to see which one has the biggest value or the lowest value. Come on. It's a place where you could maybe fast forward a little bit, but anyway, I'll hit enter there. And then we got to get to the right bound, so coming over the top, I see where the maximum is. I want to make sure I've gone far enough, and I'm actually on the downhill slope. I always go farther than I need to, but just to be safe, we see negative 3. We get a y value of 116, so yeah, it appears, 0.001, probably close enough. And then we can find, let's see, let's go ahead and find the minimum. And then this one we're going to, that's going faster. Last time anyway, here we go. That's a good left bound. I see the minimums here, so I'll just hit enter. And then I keep going till I get to the right bound, which is, to the right of where the minimum is. I see it's here. I'm to the right of it. I'll hit enter, enter for my guess, and at 7, if you round this, we get a minimum of negative 384. So our answer would be simply, so we go there, okay, this one's asked, so if this is open answer, we definitely want to show all the work, but if they're just asking for the absolute maximum, absolute minimum, find them, find the values and the location. Okay, so we've kind of done that here. The locations would be at the max, it happens at x equals negative 3, and then the maximum value is the y value is 116. Okay, the minimum is an x value of 7 with a y value of negative 384. Okay, and again, if we were asked to, really using the closed interval method, we've done this. These are endpoints. We've checked the endpoints. And then the other part of the method would be to find the first derivative. And so we would do that. We get 3x squared minus 12x minus 63. We set this equal to 0. Let's see. 3 comes out of there, but this is, 3, 6 is 9 times 7. So we can factor out a 3. We get x squared, and we kind of, the nice part about doing the graphing part is we know what our x and y answers are. Negative 3 and 7 is where we're going to get zeros, so we know we're able to factor this. We take a 3 out, then that's 3 times 7, so that's 21. So we can divide both sides by 3, so that still gives us 0. We just get the 3. It's not important. It's not going to contribute anything. And then we can factor this into x plus 3 and x minus 7, and then solve each, that x plus 3 equals 0 or x minus 7 equals 0, giving us x equals negative 3 or x equals positive 7. And we don't have to really show derivatives to the left or right here. What we can do is just, we know these are going to be either minimums or maximum. We plug these into the original function and find the values from the table. That would be sufficient. And we find that this is our maximum point here, and this is our minimum here. Okay, so yes, we did use the calculus in finding the first derivative, find where the first derivative is 0. We know those should give us either minimums or maximums, and then we just look at the values in that table. Coming back here, second table. You don't have a graphing calculator, makes it a little bit harder, but then you could plug those in by hand, and again you would plug them back into the original function up here to get the values, and we see, yes, negative 3 is 116, and 7 and 7 is negative 384. Okay, so those are the last two. Take a look at the other ones we worked through, and again review these ones we focused on, and you should do just fine.